Okay, hello. So this will be the demo for chapters 7 and 8. Much of it will actually be chapter 8, but we will do some addressing as well. So of course it will work. So basically, hopefully you can see my notepad file here. And so I've written out a bit of a scenario for it. So basically, I've got a scenario with there's a main office that has 50 host addresses required on its LAN. Then there's a branch office LAN, which I should have titled, I suppose. And that has 25 hosts required for its LAN. And then we have 2 WAN links, so they each have 2 hosts. So it's a very simple solution, but anyway. And so the network address we're going to subnet is 192.168.100/24. So what we need to do is do some calculations. So with 50 hosts, we need to figure out how many bits we need in the host section so that we can meet that requirement. And so let's start with that. So 50 hosts. So it's 2 to the power of n. 2 to the power of n, of course, is what we use as a calculation. So if we do 2 to the power of 4, so 2 times 2 times 2 times 2, we would be able to we would be able to have 16 hosts. So that's not enough. And so if we do 2 to the power of 5, that will actually, it won't give us 16 hosts. It's 16 hosts minus 2, isn't it? It will equal 32 hosts minus 2, because it's 2 to the n minus 2. So I'm still in the subnets. But anyway, so that's 30 hosts. So 2 to the power of 6 will equal 64 minus 2, so 62. So that does look like a good solution. Equals 62. So 5 bits wasn't enough, 6 bits is enough. And so if we look at, so we need a 6-bit host address. That's what's required. Now with 25 hosts, we've already pretty much looked at that. So 4 bits isn't enough, but 5 is. So we need a 5-bit host address. So of course, with this, we need a 2-bit host address. I didn't put bit in there, did I? Okay, so the WAN links are identical in that. Of course, they'll need to be a different network. All right, so we've done some calculations there. So we know how many bits are required. So if we do 32 minus 6, that of course equals 26. So we need a /26 network prefix. And so what is that as a subnet mask? It's 255.255.255. And then there's 1, 1, 1, 2, 3, 4, 5, 6. And so that's, of course, binary for the last octet. So, of course, that number in binary is 128 plus 64, which equals 192. So it's 255, 255, 255, 192. So that'll be a subnet mask. Now, when it comes to VLSM, the easiest way to not make errors is actually to start with the largest subnets first and then move down in size. And so, of course, this main office one is the largest one. So what we will use is 192.168.100.0/26. Now, if you remember, we've got 62 host numbers. So of course that 0 is the subnet number. We can't use that. So 192.168.100.1 is the first host. Um, 62 numbers, and so we can go through to 192.168.100.62 will be the last host. And then of course there is the broadcast address 192.168.100.63 is the broadcast. So that's that subnet arranged basically. So subnet number of .0, first host of 1, 62 is the last host, so we've got 1 through to 62 with host range. 63 is the broadcast, because that in binary would be 0, 0, because it's the first 2 zeros, and then 1, 2, 3, 4, 5, 6. If you add those numbers up, should equal 63. And so away we roll. So because it's the 0 subnet, that's the subnet section of that now. All right, so basically we've used the addressing from 0 through to 63. So we have to start at 64 now. Now 192.168.100.64 will be the network number. And so if we do, might do this above, 32 minus 5 equals /27. So what's the mask for that? 255.255.255 is the first 3 octets. Then it's 123 network number 12345, and so that equals 192 plus 32, and so that's 224. And so the mask will be 255, 255, 255, 224. And so we've calculated that /27. And so of course this is I didn't actually specify that as being the net number, which is what it is. First host. Sick of typing. Damn it, I didn't do the carriage return. So first host, last host, broadcast. Now, if we remember from this, with a 5-bit host number, we've got 32 addresses. And so basically the first host, of course, is 65. And then if we add 30, put a space in there. Basically from 32 it'll go all the way through to 96. So the broadcast will actually be 95, not 65. And so the last host will be 94. So basically 64 plus 32 equals 96, but of course, yeah. So we've got 30 usable addresses, so 65 through to 94, and then of course there's the broadcast. So again, this broadcast would be 1, 2, 3, no, sorry, 0, 1, 0 is the network number, and then 1, 2, 3, 4, 5. And so if you add those up, that should be 95. Now, so we've used the addressing. I'll just copy this. All the way up to 96, haven't we? Now, all right, haven't done the subnet mask yet, so we'll have to ignore these masks at the moment. So 32 minus 2 equals, it's a /30. So the mask would be 255.255.255. And then 1, 2, 3, 4, 5, 6, 0, 0, which equals, so the quick math for that would be, well, 2 and 1 are 0, so if you've got 255 minus 3, 252. So that would be the subnet mask. Now, so that's, of course, /30 is what we've calculated. Now, we have two usable addresses. So the subnet number is 96. The first host would be 97. The last host would be 98 because you've only got 97 and 98. And the broadcast would be 99. Okay. So when it comes to the last WAN link, it will be near identical to the previous one, except 4 more. So we've used 99. So the first host address, well, the next available address is 100. So, oops. Oh no, I've got whoops there. 101 is the first host. 102 is the second host. And 103 is the broadcast. And so, so I haven't actually calculated those. Now, so we've used 103. So actually from 192.168.100.104 is still available for use. So we've only just used 103 addresses for this solution. If we'd done all the subnets being the same as the first main office, I would have used all of the addressing scheme, and so no room for expansion. And so this is where VLSM is a lot more efficient. All right, so I might just save that file, just make sure I don't lose it. Now, we need to then, we've got an addressing plan. That's wonderful. But we've actually got to translate that into getting it to work. So I'll actually open up Packet Tracer and we'll actually run that in there. So I'll just change my sharing over. Okay, so sorry about the delay with this video, by the way. I had some technical and operator difficulties. So we had a look at the addressing scheme, design and addressing scheme for topology, and so this is the topology it was designed for. So there's a main office with a LAN that needs 50 hosts. There's a branch office with its LAN that needs 25 hosts, and then we have the two WAN links, one between the branch and the main office, and the other one between the ISP and the main office. So they're the networks we needed to design, and so now let's implement it and make sure it works. So on the main office router, we'll go into that. We'll so of course we're in privileged exec mode at the moment because I made sure I had the right one open. Actually, before I do that, I might just save as. Sorry, don't want to get rid of my original. Okay, so in the main office router, so of course we need to go to conft. What's going on? Conft, and so give it a host name. Main will do. Now, so we need to do the addressing, and so so we'll go int g0/0, and so that was the first subnet here. So as you can see, it's this network here, and so we need IP address 192.168.100.1 is the first host number. And then we have a network mask of 255.255.255.192. And so, which is of course equivalent to /26. Oh, what the hell? Oh, I missed a space out. That's better. And so that's that IP address. And so of course we need a no shut to bring the interface up. Now, the link between the main office and the branch office was subnet 96. So we need to go to int s0/0/0 and then IP address 192.168.100.97 and 255.255.255.252, because this is a serial link. It's a it's /30 basically. So two usable hosts. And so again, no shut. All good. And then of course we've got the link to the ISP. So that's on int s0/0/1. And so we need IP address 192.168.100. That's 100. I'll do 102 for this one. And so 255.255.252. So again, it's another /30. So we do no shut. And that should all be good. So if you go end, copy, run, start. Save our settings there. So if we do show IP route, there we have the only link that's up is Ethernet, because the other ends of the serial aren't open yet. So once I've fixed those, we will actually start getting some more networks coming up. So if we do a show run, we can have a look at what's gone in there. So the host name, and then we've got the addressing. So that's the LAN. And then we've got the internal WAN link and then the ISP WAN link. And so that's pretty much all I've done. So let's go to the branch office. Again, en conf t host name branch int g0/0. Might move this away over here so we can see the addressing. So IP address 192.168.100. Now it's subnet 64, so we'll do 65 as being the first host number, 255.255.255. Now for that branch, we have a /27, and so of course 192 plus 64 plus 32 equals 224. So that's the mask for it. We have to no shut, of course, to turn it on. And so then we've got the interface for the serial link. IP address 192.168.100. Now that was subnet 96. I've already used 97, so we need address 98, 255.255.255.252. And so again, a no shut. This should bring the interface up. So do a copy, run, start. Ooh. This is where I shouldn't have spaces. That's better. All right, so if we do show IP route, this should have two entries in the table now, yes. So the LAN network and that WAN link. So if you like, we can try pinging across the WAN link. 192.168.100.97. across the WAN link worked. I suppose if we want to do internal first, we could maybe do the host. So this is on the 64 network, 192.168.100.70 will work. And it was 224 for the mask. And it was 192.168.100.65 was the router from memory. So let's do an IP config. And let's ping the router. 2.168.100.65. Oops. Oh, that is a 5. Sorry. Some of these fonts are not great. So we can talk to our router. Sadly, we can't ping any further because none of these other devices know how to find this network. So we will cross that bridge when we come to it. So we'll do this host as well. So 192.168.100. Of course, this is on the 0 subnet, so 10 will do. We've got 192 is the last octet of the mask. 192.168.1. Let's try pinging that. IP config first. Seems to work. Ping 192.168.100.1. And away we roll. Now the major device we haven't configured yet is the ISP router. So that's the only link that's not up. So we'll go to the CLI, en, conf t, host name ISP, int s0/0/1 from memory, IP address 192.168.100. Now subnet 100, I think I used 102 on the other end, so I'll use 101, 255.255.252, and no shut. And copy, run, start. And so from there, let's just try pinging the other end of the serial link, 192.168.100.102. And we have success. So we've tested every network. So that's actually gotten it all working. Now if we go back to this router, you can see the link messages for it going up. If we do show IP route, we have 1, 2, 3. So that's all good. We've got subnet 0, subnet 96, and subnet 100. So of course we don't know about 64 because that's on that other router. Now, if we wanted to get sort of real busy, we could probably we'd either have to do static routes on all devices, or we need to set up a routing protocol on all devices. So what I'll do is I've actually prepared the config earlier. So I've actually done, configure terminal router rep actually turns rep on. We need version 2 because we've got VLSM. And then I've just got a network command which actually says this will take part in the networking. We hit end, and then I've done a copy, run, start. So I just had that in a notepad available, and so I'll do that same stretch of commands. That's actually enough to turn on RIP on those routers. Paste. Paste. And so now, if we do show IP route, might be a little bit brave looking quite so quickly, but anyway. Oh, okay. No, we've got all the routes now. And so we've got subnet 0, which was learnt via RIP. And we've got subnet 100, which was learnt from RIP. And so now, this host should be able to ping the ISP router. and have a look at that. We have success. And so that is a very quick and dirty way of doing VLSM on a on a small setup. All right, so about the only other thing we haven't covered is IPv6, which was covered in the chapters. So I'll do a very quick and dirty setup for that. So I'll just do it on the main router. So if we do conf t, now to get IPv6 working, it's actually off by default on most routers. So you actually have to do IPv6 unicast routing, and that actually turns IPv6 routing on. And then you just need to go to int g0/0, and then you need to give it an IP address, IPv6 address. So IPv6 address. Now I'll use one from the examples in the chapter. 2001:. DB8 colon acad colon and then just 1 and then colon 1/64. So that should work nicely if I haven't made any typos. So now if I exit or end, do a show IPv6 route, there is now a routing table. And so I have this directly connected network, and that is the host number. As you can see, the network number is /64, the host number is /128. And so basically that's the router working. So let's turn IPv6 on the host. So here all you have to do is turn it on to auto config, and it actually figures it out for itself. And so it's all right. So that's basically set. The host is working. Hopefully the recording is working. Now what I can do, I can also conf t. Now we can also do that link local address. So well, I'm actually jumping the gun. Let's do that show IPv6 interface brief command. And so that's that host address I assigned to it. As you can see, the link local address is one that Cisco has figured out for itself. And so that's not necessarily a friendly way to go. And so if we go into the interface, and then we do IPv6 address FE80:1, and then link local. Now if we end, I might do a copy run start just to save what we've done. If we do that previous command we did, you can now see the much tidier address. So that's basically so if you want, I can actually go to here, and if I ping FE80:1, it should work, and it did. So that's just a link local ping, and so yeah, that's basically all that's required for IPv6. Okay, so that should actually do it. So of course next week we start working on chapters 9, 10 and 11, and so we'll be looking at those then. I'll also demo a trial practical test, just so you hopefully have an idea of what you need to do for the test. Okay, I'll see you all later.